Very good morning to all. I am Anubhav Srivastava, affiliated with Department of Engineering, University of Naples, Parthenope, Italy, and I'm working in the field of fiber optic sensors and making it suitable for various interdisciplinary application. I'm presenting the research entitled Fabrication and Characterization of Arc-Induced Long Period Gratings in Optical Fibers with Microchannels to IEEE Sensors Conference 2020. And the authors involved here are myself, Dr. Flavio Esposito, Professor Stefania Campopiano, Professor Agostino Iadicicco. They are affiliated with Department of Engineering, University of Naples, Parthenope, Italy, and Joao MB Pereira. He is affiliated with Department of Fiber Optics, Rice Acreo, Kista, Sweden. So let's start with the brief overview. The core aim of this research is to make a flexible sensing platform by inscription of a long period grating in side hole fibers, which is having a drilled microchannels inside the cladding region, which can be of different shape, size, and number of holes, and being effectively employed as a mechanical, electrical, and micro-fluidic sensors. Since we are talking about long period grating inscriptions, so LPG is nothing but a periodic structure fabricated within the fiber and is realized through modification of refractive index and or geometry of core region using a periodic pattern defined by specific grating period. So the overall final effect is the presence of several attenuation dips in optical transmission spectrum, which we can see here. So the inscription in side hole fibers is being done by electric arc discharge. So we can see here is the two electrodes. The discharge is being produced by two electrodes, and then in turn it creates a perturbation in the fiber geometry. Next to it is a different configuration of side hole fibers, like there is a one side hole fiber having diameter 25 micrometer. There is a two side hole fibers having diameter 28 micrometer and having a different dimensions of from the hole's peripheries. And there is a four hole fiber having the 25 micrometer diameter. So after fabrication in side hole fiber, we obtained a different transmission spectrum for different side hole fibers. And also we can see there is a very deep and narrow bands obtained with around 30 to 35 decibels depth. And this is comparable. It is comparable with the typical LPG spectrum of standard fiber. So next is characterization. So to further assess the fabrication results achieved for the long period gratings inscribed side hole fibers, we characterized its response to different external parameters like surrounding refractive index, strain, and temperature changes. For SRI, we found the typical nonlinear response of LPG observed here with blue shift. We can see here blue shift due to increasing SRI and cladding mode order. Likewise, we obtained for the strain and temperature changes for both a linear response. Such responses are due to the effects of specific stimulus like temperature or strain on effective refractive index of core and cladding modes and on grating period. So we can see here it's almost the linear pattern is maintaining, and these are the sensitivities of strain and temperatures. So the next is application as a micro-fluidic sensor. So this is the fabrication platform for providing the long period grating inscribed side hole fiber with both optical connection and access to the microchannels for input output of liquid solutions. Next to it is testing. So the testing is conducted by using DI water inside the channels. Here we are using air and water, which is injected inside the microfluidic channels of side hole fibers. And in turn, the resonance wavelength of side hole fibers LPG monitored in real time with acquisition rate of 4 seconds, which overall this setup demonstrates the possibility to detect the presence of a liquid rapidly and consuming very low sample concentrations. So which opens the future insights for biological sensing by using this type of microfluidic sensors. Yes, of course, still the optimization is being undergoing. Thank you very much.